Hello, Chip GT here, and in this video we are going to cover all the remaining challenges associated with the DOF Links hardware. This includes the solenoids and where to place them for the best felt touch and best heard sound, the shaker motor, the controllers, the tilt bob, some future-proofing things that we need to talk about, and much more. But before that, the Casual Gamers Group founders, J-Pops, No One, Dr. Jonesry, and I have decided to break the channel down into several smaller sub-channels. You shouldn't have to do anything to continue watching and getting the feeds from me. All this is for us is a name change, and we are becoming Vpin Wizardry. This makes it easier for others to find the channel and our content because it is a unique name to just us.
Also, the voting polls are still open for what content you want to see starting in April. All you need to do is click on any of my videos and then scroll down here to the Vpin Wizardry tab, and you're just going to click right there. It'll bring you to the page. You click on Community and cast your vote. That's it.
The voting polls will close March 17th at 11:59 p.m. So cast your vote before then. Without any further delay, let's coin in and push that start button.
Okay, on the whiteboard, everything in gray we have already covered. This video will cover all the questions that are in yellow, leaving the rest being power management and wiring questions. Now I'll cover that in the next video. Alright, so this is where we left off. We had the sliding TV come in and out. We had the back door open and close. And now I want to talk about some future-proofing things. So first, I drilled a couple holes through the bottom layer here, and I drilled a hole right here. This is where my on-off switch is going to be. So I'll just go ahead and pull that in real quick. I think I put that under cabinet. Switch. There we go. This on-off switch is literally a light switch with light switch cover plate. There is another piece on the inside of the cabinet to protect the electrical connection. It's like a little box here, but I wanted you to see, the light switch here and know that that is the on-off switch that provides power to the cabinet. Now, in the future, this is going to have a computer in here, so I might need to have another button over here to put power on the computer, and if I push and hold that button, it might be able to shut the computer off. So just future proofing, we know that we might need to put another switch somewhere near the power switch so that we can turn the computer on and off, or maybe we can figure out a way to wire it to this switch. We'll see. With that, I also did the future proofing for under cabinet lighting, so that way if we're making any more holes in here, we know where the under cab lighting is going to be. So this is a RGB strip that will plug into the same network of lights that are up here. And I haven't decided if I'm going to make them all on one color or if they're going to be addressable. It'd be kind of cool to have some under cab flashing, when things go crazy. I think I might do that, but we'll talk about that in the next series, which is continuing to make add-ons and toys. I also wanted to talk about some of the airflow. So here's the airflow. I went ahead and I modeled some fans and I put them in a place where I thought that they would be, best. So there's those holes there for cooling. And then we have the cash box. So I know that I wanted to make the cash box part of the things that you guys vote on. And during some preliminary research, I found out that the way I built my cabinet really doesn't accommodate for a cash box. So I ended up putting my coin door right smack dab center in this cabinet. This is a full length door for a cabinet, but I offset the base of my cabinet by about 1 inch. And I also mounted my coin door about 1 inch too low. So Most cache boxes are 4 inches in depth, and they're about 9 inches back, and then they're also much wider than this. This caused a problem where I could not purchase a cache box that's used in real life. So I could, but what I would need to do is I would need to either rebuild the entire front panel and drop this down about an inch and it would fit. I didn't want to do that. I've already put too much time and money into making this front cabinet and putting the bottom panel where it is. So we are going to 3D print a custom cache box that's a little bit thinner. So here's the design that I did, and it is a full length cache box, but it is half the depth. This is 2 inches from the bottom here to the top up here. And it's much more narrow than a regular cache box because, let's be honest, we don't really need a place to collect coins. What I'm going to use the cache box for is when we're taking this on tour and taking this around. This is where I'm going to put my tools. So any of the tools that I need to put the legs on and, you know, screw down other components like the back box, all those tools are going to go in here. When I have the legs removed, the bolts will go in here. So having a cache box, a lot of people don't realize this. Cache boxes, even in real pinball machines, are used for many different reasons. So a lot of people that I know who actually have pinball machines, they use the cache box to store parts. When parts go bad, they keep all the original parts. That way when they sell it, they say, hey, I've got all the original parts. So the cache box is a place where a lot of people put those instruction manuals. This is a great place to store those instead of like on the side of the cabinet, like mounted to the side. That's what people use cache boxes for if they're not used in a professional setting. Most arcades use a card system, so you swipe the card to add credits versus adding coins, and they use the cache box for the same thing. This is where they store all the parts that they would need to do maintenance on the cabinet. So that's why I'm going to make a cache box. This will save us some money because I already have a printer and I already have some filament, and we are going to 3D print this. It'll be our first 3D printed part, completely 3D printed part. And it will line up with the coin mechanisms so that coins can actually drop through down here if I want. And this is the appropriate angle for when a coin hits it to slide back as far back as it can go before it falls over. So maybe we can make the coin in option like a donation, like on the coin door on the front when we're out on tour. We can say, hey, you know, add a 25-cent donation to the cabinet, you know, and that would not only just give them a coin in, I mean, we'll have free coin in options, but you know, it'd be nice to have like a donation thing. So those are some options for having a cache box. All right, moving on. The SSF audio. So I went ahead and I added this in. We've already talked about this in another episode. So there's all the SSF. I went ahead and I modeled it in, and you can tell the things that I modeled versus what I imported. Like this was imported, this was modeled. But I went ahead and I added in the location of all the SSF components. All right. And I'll just zoom out real quick. You can see that I don't have this audio puck right up against this hard body or this hard body on the front. So this is going to give us some good range right here. You're going to be able to feel it if your hands are near the buttons. It'll be really nice. Sorry, I'm like flashing the screen here. Don't mean to do that. And then in the back, we have the same thing. We have this big open area back here, and we'll be able to vibrate all the wood around here. Keep in mind, this is a hard surface. This is going to be a hard surface, and this is a hard surface. This is not considered a hard surface because it will open and close, and there's a little bit of a gap between the panels here, so this does open and close. So it is not considered a hard surface that will affect this audio. In the past, I went ahead and I mounted the audio amps to the back door, and my thought was, you know, I want to keep the audio amps out of an area where it would take up space on the base down here, because I eventually want to put a computer in here. So I'm trying to reserve this whole back side of the cabinet back here for the computer. However, I have noticed that opening up this back door to adjust the audio settings is kind of a pain in the butt. So I didn't really have the foresight to think, hey, I'm going to need to adjust these things, like the bass, the treble, and all that. So now I'm reconsidering where I might want to put the audio amps. So this is the audio amp for the back box speaker. This is a future-proof thing, but I was thinking about making a little tower, making a custom like 1/8 inch wood tower and mounting all the audio receivers right here. And some people, they will mount them to the base of their apron, or they will make a shelf here. Well, if I make a shelf right here and put all the audio amps across it, it will act as a dampener or a buffer for the acoustics of the audio pucks. So I do not want to do that. I'm going to try to build a tower here and just stack all 3 audio amps right there, so that when I open the coin door, they're right there, they're easy to access, and I can make the adjustments. And by making a thin coin box, that makes the other half of the coin door, so you can see that the coin box takes up just a little bit over half, but this gives me enough room where even if I wanted to move this over, I could, and I could adjust the knobs and everything. This is more than a hand's length's width here, so that gives me some good options for where I might want to put that. I added to the cabinet the buttons, not the plunger, just the buttons. So I had to build these so that we knew where some wiring things might be because of some of the DOF Link stuff in the future. So you can see that each of these are at an angle so that we can wire and have all the wires come down here, and we'll have like a wiring bus here. And then these guys, they can just, tap into that wiring bus there. And then the same thing here. I have this side turned off, but it'll be the same thing. There'll be a wiring bus that comes either, up and around over here and down to the controller, or it'll come down over here to the controller. But we're going to talk about wiring in the next video. After I put the buttons in, I decided it was time to go ahead and put in some DOF stuff. So over here, we're going to start with the flippers. So there they are. These are the solenoids for your flippers. Now, the solenoids serve 2 purposes. All right, they give you some felt touch, and they also provide some audio. So there's a couple of places that you can mount these things. So my flippers use these custom boards. This is just a hard sketch of those boards. And what happens is this is the flipper button, so it'll be wired in to this port down here. All right, and then the solenoid, which is right here, this is your positive terminal, and you just connect ground up to one of the base wires. But here, so here's a solenoid. You're gonna have, your positive here, your negative is going to be just on the space plate. You're not going to use these end terminals here. All right, this is a car start solenoid, and there are a couple of other wires for a car that hook up there. We're not going to worry about those. All we want is positive and negative. They come in and they're going to plug in here. This port, this little port right here, this is your 12 volt power in. So this is going to come down, either come up and around down this bus that we're going to create, and it'll plug into a 12 volt power supply directly. All right, so 12 volts in. This port will go down to the KLZ board, and this is where when you push a button, it connects through, and this is essentially a relay. So, we're going to have a life extender, and we have a 12 volt board that will control our power. And then in between, there's other little circuits and microchips in here. There is a relay, if you will. So when you push this button, it'll come down, and then it'll connect over to here and go down for your input. This makes it so that you don't have to do any programming with DOF Links, and that is wonderful because it allows the solenoid to fire anytime you push that button. So even if you don't have any tables loaded, when you push that button, it's going to fire. All right, so these boards actually free up 2 positions. So doing it this way frees up 2 positions on the KLZ board for other toys that you might want to add in the future. which is a good thing. I thought that was kind of nice. And then this also gives you some feedback on tables that don't support DOF links. So I was like, this is actually a really cool idea. I'm going to go ahead and put that on there. And it's honestly, it's not that much more expensive than just buying 2 extra servos and plugging it in. So if you want to think about that when you're looking at your KLZ options. But yeah, so switch down to the board, 12 volts in, solenoid fires. All right, now with these, you want to consider where you want to place your flipper solenoids. So on a real cabinet, let me turn the sled back on. So on a real cabinet, the flipper solenoids are kind of near the apron, and they have arms and extensions that come up to where the flippers would be in this area, and they would flip. So I decided I wanted to mount mine in a location. You know, if you look here, we have our plunger. So putting it on the side wall is not going to be an option. So on the side of this is not going to be an option for where the plunger is, because the plunger is going to go almost the full length of the apron right here. I haven't modeled it yet. I will in the next video. But having the flipper solenoids near the apron is kind of a good thing. You could mount them to the bottom of your apron. I did that originally, and I found that if I ever needed to remove the apron, that it added extra things that were a little bit of a pain. I may have to move these in the future again, because if I put in a lockdown bar, or like I have a lockdown bar, but I don't have the receiving tray where it locks into. And if I add that receiving tray, these are going to have to move. So this location on the back side of your front right here, like I could just move those down, and I'll move the solenoids down just a little bit. And it really doesn't interfere with the coin door operation. It doesn't interfere with anything else. But having these, you know, in this location, you can really feel them. Like it's very close to where the flipper buttons are and where the audio sound normally is with this apron. I mean, it's off a little bit, but it's still, you can still feel it and you can hear it, and it sounds pretty realistic. Now, if you wanted to mount it to the bottom of your apron, you can, and you will still get good feels, because the solenoid is mounted to a rigid surface that's then mounted to the side. Having the solenoids on the apron just gives you a more realistic location to where they would normally be mounted, and it really is up to you with how you want to do it. I just wanted to be able to remove my apron if I needed to get access to anything around the coin door without having to disconnect and remove 2 extra pieces. So in the future, I might have to move these down, and I can do that. There's plenty of wiring for that, and we'll talk about that later on. All right, so after you have your flippers on there, so I'll give you a top-down view so you can see. And having them right here, I mean, you're still going to feel them, and they're pretty close to where a real flipper solenoid would be. Sometimes they're angled, and placement for these, I have found it doesn't matter how you place them. It matters, you know, spacing how you place them. Okay, so you can have them mounted vertically like I have. You can flip the vertical, like you can have the bottom of the solenoid down here and the top up here, and it still feels the same. You can have it on its side and it feels the same. But having it mounted to the front of the wood here, you're gonna feel the bang on this front panel. If you have it suspended over the apron, you still will feel it, but it won't be as strong or powerful. And if you mount it to the side here, you're going to have some issues. You might have to mount it a little bit lower, like near this audio puck. Now, this is not going to have any extra resistance for the audio puck, but having it down near the audio puck, you know, is not a bad thing. But I wanted to be able to have, you know, the bang bang noise and the bang bang feels whenever I flip my flipper. So this for me worked out best, but anywhere around this area will work out for you. You can have it on the side, you can have it on the apron, you can have it on the front, doesn't matter. This one is fine. For the slingshots though, so let's turn on some slingshots. Not the cabinet file, but DOF. When we turn on the slingshots, you'll notice that I have them up a little bit, okay? In a real cabinet, here, we'll go around like this. So So you can see the screws here that go into the wood. On a real cabinet, you have flippers here, and your slingshots are just above that. So I was looking at the position on my screen, and I had a table loaded to kind of like you can just load any table, and the slingshot position is pretty much the same. So it was right about here. All right. And on a real cabinet, the slingshot solenoids might be in this location, they might be inverted here. So having it in a line in this area, kind of near the bottom of the TV, like 6 inches below, is where the slingshots would normally be. And again, it doesn't matter how you mount them, it's all about the location. You can have them forward, backwards, upside down, right side up. This just made the most sense to me because this gives me more options for spacing in the future. If I wanted to add, more DOF hardware on the side of my cabinet, I could. And this worked out best for me. And you can see that it's kind of in line with the leading edge of the sled here, and it's about 6 inches below. Well, maybe it's a little more than 6 inches, but it's right below the front of the TV. It feels like a perfect location right here, and you can hear it, and it sounds like a real slingshot firing. All right. Next, we have the mid-range. When you buy this kit from Cleveland Software Designs, he gives you a couple of rails here, and I wasn't sure if they would fit the full length of a wide body cabinet. It was actually more than enough. I had to cut it down. So he gives you more than enough to make a rail that comes across, but there are several different design plans that he offers where you can have a rail along the side, and you can have a solenoid here, a solenoid here, and a solenoid here. I chose because in the middle of the playfield, there are sometimes other features like a virtual up kicker. I chose to follow Terry Red's plan, which is you have a left center, a mid center, and a right center. And I put it across a cross member, and then this is the controller for this is the the solenoid savers. This is like a board that you put on, and I'm going to go ahead and remove the front panel from the cabinet real quick. Boom, gone. This board controls 4 of the solenoids. So you have 1, 2, 3, 4. They plug in here, and you go 2, 3, 4. But where's number 1? Number 1 is actually the left slingshot. All right. And one of the biggest questions that I had was, would I get enough wiring to go from here to here and cover the rest of these guys? And the answer is yes. Cleveland Software Design knows that some of the plans that they provide has different lengths of wiring, and they give you the full length. You will not have to buy any extra wiring, which was a very nice thing to find out later on. And then these on this side, this is the wires that plug into the KLZ board. So this side is the solenoids, this side is the KLZ. I put the KLZ side closer so that I didn't have to run more wires. So these are relatively short. This is fairly long depending on where you put your KLZ board, and we will talk about that in just a minute. Now, next we have the mid-range, and we have a back range. Oops, that's the cabinet. So here's the back rail and the back range board. So I call them ranges because it gives you a wide range of sound coming from a certain location. All right, so same thing, almost the same exact setup, only number 1 is not this one, it's this one. All right, so number 1 comes down and follows around and comes under this rail and plugs in here. And then I had enough wire left over from this first board to make this really long wire because several of these are really short. So if you all the wiring that he gives you is cut to one really long length, and you have to manage your wiring that you have. So I said, okay, I don't need a whole lot of wiring to go from here to here. I'm going to use that extra length to do this solenoid, and it's, I think it was like a green color or red color or whatever the positive is in the ground, but you get more than enough cable. You do not have to buy any extra cable to make that long distance run. Or the long distance run to come from here down to your board, wherever you may place it. As long as it is somewhat centralized or in a central location, you do not need any extra wiring. If you decide to mount your KLZ to the side here, you know, you're going to have extra wire. If you try to put it down here in the middle, you may need some extra wire. It's that tight, but it was enough where I didn't have to get any extra. And once again, I decided we'll place some down. I did lots of testing beforehand in all kinds of different locations. And I found that, you know, Terry Red and Major Frenchie, they use this particular setup with 3 in the middle, 3 in the back. Now, the ones in the back almost are always for your pop bumpers. So every table has like 3 pop bumpers. So in the software, Terry Red has done, you'll normally have like 1, 2, and 3 set up for pop bumpers, and then this might be a virtual up kicker, this will be some like a deflector, this will be something else. You know, these always stay the same. The front 4 always stay the same. These in the back can be used in a number of different combinations, and Terry Red, Major Frenchie, and a lot of other people recommend this particular setup because that is how they're programming those tables, and this gives you a range of a whole bunch of different things that these could potentially work for. Now, if you look at a side cut view, this gives us 1, 2, 3, 4, 5, 6. You have 6 different ranges for audio, okay? And for the feelies, you have, you know, 1, 2, 3, 4, 5. You don't really ever feel the back, but you can hear it. And this works great. Like the audio covers any of the range in between here. And recently with like the Totan 4K, I noticed that I heard, you can hear friction. There's like a spinning lamp in the middle, and you can hear friction in the middle of the cabinet of it spinning around, which I think is so freaking cool. And then you also have all of, you know, the pops and the clicks and the bangs, and this gives you the best coverage, the best range. If you wanted to go with a 12 solenoid range or 12 solenoids, I don't really know of too many people who are actually using the 12 solenoid configuration, but the 12 solenoid configuration, what it does is it makes it so that you have like an extra one here and an extra one here, or you could put one here in the middle or one here in the middle. It really doesn't matter where you put it, but not many people go with the 12 solenoid setup. Most people are sticking with 10. 10 is fine. I really don't know how the programmers are using 12 if they decide to go that route, but this gives you really good range, and it sounds and feels like a real cabinet. That's just my opinion. You don't have to, you know, take what I say for, you know, for what you want to do. If you want to do 12 solenoids, go for it. All right. Now, next, we're going to do the shaker motor. So there's the shaker motor, and, you know, a lot of people are like, well, where should I put it? Well, this is where Stern, Jersey Jack, and almost everybody puts a shaker motor. It's right next to the power button on the right-hand side. And I was like, well, if we're going to do it, let's just go ahead and put it there. It's not too bad a location, and you know, by having a location to the far right, this cabinet, the whole freaking thing will shake like crazy. It's like an old washing machine. Sometimes you can feel it vibrating across the floor. You know, it is a very powerful shaker motor. You do not need to worry about where to place this. If you just put it off here to the side, know that we're going to put our KLZ board on the other side so that the shaker, when it's shaking, doesn't really mess with the accelerometer on the board. So next, so here's the KLZ board, and I have the USB cord come down this way, around, and go out the back. And then the only cord that's coming across right now is for the shaker motor. It comes down this way and over and plugs into port 12. The mid-range plugs in here. The back range plugs in here. And then the plunger and the buttons that I have plug in right here. There is another piece to this that is right here. I didn't model it, but this is where the expansion board goes. And I'm thinking that somewhere in this area would be a good location for an expansion board, or I could mount it to the sidewall over here, and then if we end up doing the bells and chimes, we will put the bells and chimes somewhere over here. Now notice that this is the 12-volt power supply right here, and it plugs in I want to say somewhere in this area. I don't remember if it's on this terminal or in this terminal, but 12 volts comes in here, 12 volts goes down out this way and up to this one, and then I carry over a other cable over here for this one for the 12 volt power, and then I also put in an array right here for 12 volt power. But on here, notice that we have the relays for the solenoids, and the solenoid savers are on the expansion boards that are up here. This is where you'll plug in your solenoids, and these are car solenoids, but that's why this is where you'll adjust your low end to bring up the low power if needed, if you're using a real pinball solenoid. All right. Next, let's see, what do we got next? Oh, the plumb bob. So I put the plumb bob over here kind of close to the board. Why? Well, this is where plumb bobs are on real cabinets, and you don't have to be as accurate as where I have. Like, I actually went to Mark's house and measured where a plumb bob should be. And also note that this pinball is perfectly flat right here. It's not going to be like that. It's actually going to dangle down at an angle, but I did not want to take the time to put this at an angle. I'm trying to keep it flat for modeling purposes. So I'm just going to leave it flat for now, but know that it's actually at like a 3-degree angle when it hangs, right? And then you plug in, either ground or the connector for the switch to come in right here. And then you can make this one ground, you can make this one switched, it doesn't matter. And what happens is when the plumb bob moves around and makes a connection, it triggers the switch for tilting, right? That covers everything that I have for DOF Links right now. All right, now in the Pinscape software configuration tool, this is where we're gonna go to configure our buttons and our outputs. So let's start with buttons. All right, so here's our buttons. We can have up to 23 different buttons. I currently have 24 selected. I don't really know if I need more than this. I think this is plenty of buttons to get and play pinball. Let's go ahead and take a look at our outputs. So here's our outputs. And you'll notice we actually have a ton of outputs, 22 total. Now, the board that I got from CSD only really allows for 12. I think it's 13 outputs, with 12 being reserved for the shaker motor and 11 being like a knocker, which I don't have. And then the rest of these, you can see these are the high end. So I'm firing, solenoids right now. I'm sure you can hear them pop. So they're popping. We have plenty of options for more things. Like we can have 14 and 15 be the bell, 16, 17, 18 be the chime array, and we still have plenty of outputs for more things like additional lights. So with that, this is how I've got mine configured. So that is the left slingshot is 1. 2 is the left mid-range. 3 is the mid-range. 4 is the right mid-range. 5, which was open, is now my spinning dome light. 6 is the right slingshot. 7 is the left back range. 8 is the mid back range. And 9 is the right back range. 10 is an open channel right now. I can use that for whatever I want. 11 is an open channel. 12 is the shaker. And 13 is also an open channel. The rest of these do not work with my current CSD board. This is why I need the expansion board. And then if I wanted to add a joystick, I could add a joystick for some pin maim, which I'm not going to do. I have an arcade machine that I have set up for that. But if you wanted to do that, you could set up a joystick, and this is where you'd calibrate it. And then finally, this is where we set up and calibrate the plunger. So if I pull back on the plunger, that is the potentiometer moving in real time. And then in here in the settings, you know, the Pinscape board is the main board. These are all the different other boards that you can get that are all-in-one, you know, setups like Rigmaster and the KL Shield. You can get all of those and get all your inputs and outputs, but you will not get any of the servo savers and some of the other things that are essential that you might want to consider. All right. Later on down here throughout the settings, this is where you can even set up an IR TV remote to it. You can set up some Wi-Fi and Bluetooth devices. You can set up a joystick. This is where you configure your accelerometer so it knows what position it's in. I always do 1G, which is, you know, what the original Pinscape board has. I don't really mess with any of these other things unless you really need to shake the crap out of your table. And then this is where you select your plunger. So there's a bunch of different plungers on the market now. I'm using a potentiometer to make it easy. This is where I was saying before, you really got to know what you've got and how to set it so that it works properly in the software. All right. If you have a launch button, you can, you know, say, hey, I've got a launch button and this is where I want to enable it. I have my launch button hooked up to another button controller, and I'm not going to worry about changing that. You can configure quiet mode. So like if you push, you can say this button is my quiet mode button, and in quiet mode, it turns off all of your solenoids. So you can make any one of these buttons turn on quiet mode. You can make any of these buttons also not operable when quiet mode is on. I don't really mess with any of these chip controllers. I don't recommend it. If you have a momentary switch, which is like you push a button and it springs back out, or an on-off switch, this is your Pinscape After Dark mode. So this is where you would set up the, you know, turn off the solenoids if you have like a baby and you don't want to wake them up because this thing bangs and fires and goes crazy. This is also where if you wanted to have a switch to when you open your coin door to kill high power, you could do that through here as well. And then you can also assign a light. Like if this has a light inside of it, you can assign a light and say, hey, turn the light on so that I know what's going on. And then this is where you can control your options for your lights. Like you can change colors, and like these obviously are the outputs for the solenoids, but you know, you can make them outputs for lights. You can make them outputs for all kinds of different things. So this is where you go and you configure your various outputs. So you can see I've got a ton that are not currently in use. But from here, now you know how all the software is configured for this. One of the things that I want to talk about real quick, and this is more of a future-proofing kind of thing. So let me remove the TV and sled. I want you to notice that where I have the mid-range is almost the middle of the cabinet. I am putting everything for DOF Links and SSF, cooling, cashbox, all that bells, chimes, and whistles I want to put on this side of the cabinet. And the reason for that is I want to reserve as much space as I can on the back side for the PC that we're going to buy in the future. And I want to be able to either have the PC slide out, or maybe we can make like a bottom tray that folds down to access the PC if we need to, for like cleaning and other things. But I don't know what PC we're going to go with yet because I haven't started doing the research on it. And I want to try to keep as much space back here available for a PC. Or what we could do is we might be able to mount the PC, if it's a small one, on the back side panel here. That way when it goes upright, we don't have to worry about all that spacing on the ground. This gives us enough room here for just the motherboard and maybe the graphics card, and that'll go up to the monitors there and over to the monitors there. I haven't quite decided how we're going to do that yet. That is going to come in the future, in the April videos because we need to start talking about all of that and the modeling for that. I'm going to go ahead and starting next week, I am going to start modeling out all the other components, and we will talk about where the future of DOF Link stuff might want to go. We might put like a bell array, you know, over here on the far wall, and we might put the chime array on this wall. I don't know the dimensions yet. Right now I'm reaching out to people, finding out costs for the components and trying to find the best prices. And there's a lot of people in the community who have electromechanical arrays that, you know, they're just junking. So if you're looking at possibly getting an electromechanical chime array or bell array, I should be able to find them for pretty cheap. You should be able to too, but it's always best to reach out to people in the community who are looking at junking them. And, you know, solenoids are fairly inexpensive. Like these guys were $10 if we wanted to use a knocker solenoid on the bells, and we're using knocker solenoid on the chimes. I'm going to need five more channels. The next video, we are going to cover power management. So the power injection, how I ran all the power for all the lights. And, you know, I ended up putting these holes here so that we can inject power and do lighting there. The lighting controller is not in here. So the next video is going to be all about power management and the lighting board that is up here. What you want to see next, I'm going to start modeling out whatever is in the leading position starting Monday. And then we'll just go from there. Thank you everyone for watching, and I'll see you next time.